Hello and welcome to today's European SharePoint, Office 365 and Azure Community webinar. My name is Laura and I'm delighted to be joined by Olena, who will present the topic, Harnessing the Power of Digital Transformation with Azure Cosmos DB. Remember to join in on the conversation about today's webinar and more on Twitter. Our Twitter handle is @EuropeanSP and our hashtag is ESPC23. Don't forget to check out the Resource Centre. This is updated daily with the latest blogs, ebooks, webinars, and how-to videos. Simply visit sharepointeurope.com/resource centre and click the Content tab at the top. Continue your learning by joining us for the final webinar of Azure Week, which takes place tomorrow, Thursday, July 20th, from 11 a.m. to 12 p.m. CEST. For full details, please check out sharepointeurope.com/register for webinars. You can now watch the European Power Platform Conference 2023 showreel video from Dublin last June. Just last month, over 1,200 Power Platform professionals gathered in Dublin for the European Power Platform Conference 2023. Check out our amazing showreel video full of highlights from Dublin last month. Next year, we're taking the European Power Platform Conference to Brussels alongside over 1,500 of your professional peers. You can expect world-class expert guidance to help you succeed in your projects and career, and not to forget an unforgettable experience in the city of Brussels. You can register your interest for the European Power Platform Conference 2024 in Brussels at sharepointeurope.com/European Power Platform Conference. Europe's premier Microsoft 365 and Azure Technologies Conference occurs this November 27th to the 30th in Amsterdam. With access to over 100 world-class speakers and over 120 expert sessions, there is endless knowledge to gain at ESPC23. Microsoft technologies are advancing rapidly, so stay in the know by attending ESPC to hear from the greatest on the very latest. Get your early bird discounted tickets for ESPC in Amsterdam this year and join us to learn and better master Microsoft 365 and Azure. Visit sharepointeurope.com to secure your tickets at this discounted price. So after the webinar, we will have a questions and answer session. You can type any question that you might have into the questions window, and questions will then be selected and answered at the end of the webinar. This webinar will also be recorded and added to the Resource Centre, where you will be notified by email when it is available. So now I'm going to pass you over to today's webinar presenter, Olena. Hello, Olena.
Hello. I will start from sharing my screen. And if you just give me a little heads up, if you can see it, would be great. Yes.
Yeah, that's perfect.
All right. So I will now jump right in the presentation. Of course, I will start my presentation from a little introduction about myself. But first of all, today's session will be about Cosmos DB, Azure Cosmos DB. So I will give a little introduction, well, full introduction in Cosmos DB. We will have a look on the features and what we can actually do with this technology. So first of all, this is my Twitter handle. You can scan it. You can connect with me on Twitter if you have any questions, comments, or just want to stay in touch. Please feel free. A couple of words about myself. So I'm Microsoft MVP. I'm also a software consultant in Experian Germany. It's Experian company, part of Xibia. Also, I'm international public speaker, and I'm quite often presenting in different conferences and online meetups. And of course, I'm also part of a global Azure admin team. So we are organizing every year a global event related to the Azure technologies. And that's also one of the reasons why I'm today here, because I like to share my knowledge about Azure and everything which is related to it. So introduction to Azure Cosmos DB. Let's start from explaining what is actually Azure Cosmos DB. So it's a globally distributed multimodal document-based database. So as you can see on the picture, there's a lot of small, tiny icons there, and I will just explain shortly what all of this means. So the first row that you can see, it's a amount of APIs that Cosmos DB supports. By default, when you created an account in Azure and you want to have a Cosmos DB, you will have the middle one, which is called SQL API. But they also have a table API, Cassandra, MongoDB, and Gremlin. So you can have a choice of any of those on the account level. After this, you can of course see the key value column, family, document, and graph. That's the way how the things are getting stored in Cosmos DB. And they are guarantee, besides the global distribution, also elastic scale out. What it means elastic scale out, it's a horizontal scaling. So when the Azure is storing our data in Cosmos DB, they simply adding more machines to store our data. And just in a few moments, I will tell a bit more about this. They also guarantee I have really low latency and 5 different consistency levels besides the comprehensive SLAs. So what are consistency levels? This is quite a complicated topic, so I just will mention that there are 5 of them. And Azure Cosmos DB is the only database that has actually that amount of consistency levels. The default one is always sessional one, or you can choose between the eventual or strong consistency, but besides this, there's also 2 more different levels. Going a bit further, what about global distribution? So the first thing I said is a globally distributed database. So when we're talking about the global distribution, when we're talking about modern applications, it means that we want to have a high responsiveness and always to be online. To achieve that kind of low latency and high availability, we want to have our instances of applications deployed as close as possible to users, as close as possible to us, basically. So for that kind of applications, they called globally distributed, and they require to have a globally distributed database as well. And Cosmos DB is, in our case, exactly that kind of database. So we can transparently replicate our data anywhere in the world and enable the applications to operate on the copy of the data, not on the actual original database, but on a replica, or basically nodes, otherwise can be called. And as you can see on the screen, so when we are making a request, the Azure Traffic Manager will distribute our requests across the regions, depends on where we are. And our regions will be able to communicate with Azure Cosmos DB with different replicas and with different instances of database. Moving further, as already mentioned, to create a Cosmos DB, we need to first have an account. So what it means to have an account and how many levels of elements we have in Cosmos DB. The account is the first thing we need to have for Cosmos DB. But to have an account, we also need to have a subscription. So when we are going to Azure portal, the first thing we need to do is to create a subscription. Then we can go to the Cosmos DB services and create an account. After creation of the account, we can create a database. And then you can start seeing the hierarchy of the items on the picture. In one Azure Cosmos DB account, where you select actual the level of consistency, that will be the same for every database in this account. You can also select an API that will be also the same for every database in this account. But you can have multiple databases in one account. After creating a database, you can create multiple containers. As you can see on the picture, container is different across different APIs. So depending on what you're actually using, it might be representation of a collection, table, graph, or something else. But I would just say that it's more like a grouping of the documents based on certain properties. So when you're creating a container, you have to provide something called partition key, and we also will get into this in just one moment. But you basically have to specify how do you want to group your items in a certain container. So container can have different things besides actual items. You can have the stored procedures there, user-defined functions, triggers, conflicts, and merge procedures, and all the other stuff. In one actual container, you can also have multiple items. So the item in the default setup with using SQL APIs will be just a simple plain document. When you're using different APIs, for example, for Graph API, Gremlin, it will be a node. but you can also have a row or edge or some other things as well. So just to repeat one more time, the structure of Azure Cosmos DB is going from the subscription level to Azure Cosmos DB account, and then from the database account, you have the actual database, and then you go into the container level, and after container level, you have actually items. So I already mentioned that you need to select something called partition key when you are creating a container in Cosmos database. So what is partitioning in Azure Cosmos DB? On a database level, we can create multiple, in a database, we can create multiple containers. And every container has to have a partition key path value set to a certain property in your document. And your documents will be grouped or arranged based on the value of this property. So imagine if you have a user document and you have a property as age and name and ID and so on. So you can create two separate containers and provide for first container partition key called age that will pick up an age property value. For example, I'm 28, so my documents will be stored under the partition key path age, but grouped by value 28. So everything that is related to this will be in one group. And another container can be can have partition key path name. So every document that has my name in there will be stored in this group. So I can have multiple different documents. One document will be giving the details about me, another will be given some short overview, but they can be stored under the same partition key path. Those groups they call logical partitions. So you can have multiple documents stored under this partition. And every of these documents will have the same partition key value. The difference only that ID of the document will be always different and always unique. So as you can see on the picture, this one logical partition is one group representation of documents in your container. And you can have a partition key, which is signed like PK. It will be equal to certain value. For example, Olena, and every document will have partition key Olena, Olena, Olena. But the idea of every document will be different and absolutely unique and cannot vary. It cannot repeat itself. It cannot change. If you wrote already the document with the partition key Olena and ID of the document will be 1, 2, 3, you can't change it. It has to stay like this. So this is how those things are getting managed on our level. So this is something depends on us to provide all those rules and strategies of actually grouping those items, those elements. But if you will go a bit on the lower level, what is actually happening underneath all this structure? There is something else what is called physical partitions. And sometimes it might be very confusing because both of those things called partitions. But physical partitions is something that we cannot control absolutely. This is none in our power to actually do anything about it. This is how Azure is storing our data. So logical partitions, documents in one logical partition will always lay in one physical partition. But logical partitions from the same container might be distributed across multiple machines. So physical partitions, it's actually machines in data centers. And because one of the logical partitions might be up to 20 gigabyte, let's say, 20 gigabyte, and container might have 50 gigabyte of data, that might be a case that physical partition will have no space to fit the same logical partition, the logical partition from the same container on the same machine. So they will just move it to a different machine. And for us, it doesn't really mean anything as long as we are querying the data from the same logical partition. But our cost for Azure Cosmos DB, for using Azure Cosmos DB, will go really, really high if we will try to make cross-partition queries. So that's the actual name for that kind of a querying. We can have a point read or just a plain read of the documents from one logical partition, and we will access one physical machine. But if we need to get an aggregated data from different logical partitions, it means that there is a high chance of accessing different physical machines, which will lead to really high latency, low availability, and high cost of Azure Cosmos DB. And talking about the cost, actual cost, Azure Cosmos DB is not calculating things in cents, dollars, or euros or something like this. So when we are actually making a request, when we are trying to access some data, we are talking about request units. So how many request units you will actually spend of trying to access one document. And request unit is just a measure of computation cost. It's how much memory, CPU, and IOPS operations, so input-output operations you're doing. In our case, I can give you an example with Azure Cosmos DB, for example. To read one document that is no more than 1 kilobyte not bigger than 1 kilobyte, you will have to spend only one request unit, and this is the minimum amount that you can actually have. If you want to write a document that is less than 1 kilobyte, you will have to spend minimum 5 request units. So you can't go lower than 5 request units when you're doing a write operation. But that's actually how the Cosmos DB works, because we want to enable, we want to optimize our database very often for read operations. We are making our writes a bit more expensive, so we are writing a bit more, and we are duplicating or replicating or denormalizing our data. But that allows us to actually have really fast reads and pre-calculated queries stored in our database. And moving a bit further, Azure Cosmos DB have another feature called change feed. So when we are changing anything in database, it's all the things will be stored in change feed. Change feed is basically just a history of all the operations, all the documents that are being written, being changed in the Cosmos DB. But this is not just what changed, what happened. This is not just the log of the changes, but this is actual document. Every time you change it, there is a new copy of document is being stored in the Cosmos DB. And so it's a persistent record of all the changes in the container, and every container has its own change feed, basically. So if you would like to know what it was happening to a certain container from the very, very beginning, there is a few ways how you can access this information. The first way, which is the most complicated, and I would not recommend using it unless you really want to transfer all your data from one database to another data storage, is called pool model. So you can access a change feed of the certain container, you can connect to it, and you can pull all the events that happen to your container from the very, very beginning. The drawback of this, that you have to handle all the exceptions, you have to maintain it, you have to deploy it, you have to also choose what partition you are accessing, not only logical but also physical partition. So you have to say like what machine are you accessing and that kind of things. This is very complicated way, but for one-time pooling of all the events, that would be a right way to go, because you can just do this once and then forget about the servers that will be doing this and just move on. Change feed also listening to all the changes that are happening. So besides being able to pull the things, you can be notified about the actual event. And this is called the push model. So if you want to just receive a notification that something happened, or basically have a trigger that an update was written or document was created in a certain container, you can create something called change feed processor. And there is a library, so basically you can use an SDK for this. And with this library, you can write your own way how you're processing all those events. So every time when the document will be updated or written in a certain container, you with the change feed processor can connect to this container. So you specify in what database you want to listen, and what container you want to listen. And every time there is a change happening, those changes will be pushed to you. This is pretty good way of working with change feed and consuming all the data, all the information that is happening, all the changes that are happening there. But you still have to maintain it, you still have to deploy it, publish, you still have to handle exceptions. But it's much easier because this you have an abstraction level on top of pool model. So basically, it's not completely different way. It's just SDK is making your life much easier, doing all the things of pulling all this data and listening to changes for you. And the last way, known for me at least, I mean, the last way of directly interacting with the events on the change feed is using Azure functions. This is very similar to the previous way that I mentioned already. It also will be like a push model. But with Azure function, you just need to specify what database you're listening to, what container you're listening to. And using Cosmos DB triggers, bindings, input or output bindings, you can like process your data basically in almost real time. So you just have to write this function and you have to publish it on Azure. And Azure is taking care and managing all the information for you. So this is much more easier to work with the Azure Cosmos DB change feed. And now you can see that basically using this last approach, you can have multiple Azure functions, and this will allow you to process your data and create so-called materialized views. Materialized views is not something specific for Cosmos DB. This is actual pattern, and it was accessible. It exists in all the other databases. It's just an approach of storing and pre-calculating your queries for the later optimized reads. So you can have multiple Azure functions that will be listening to the same change feed, to the same container, or to different containers. And for example, if I decided to change my age, I can have multiple Azure functions that will, one of them will update my age on some like kind of a dashboard or some aggregated overview. Another one will notify me by email that I changed my age on certain resource or something like this, and so on and so on. So as you can see, working with change feed is quite flexible using different Azure services. And beside this, Azure Cosmos DB has a lot of integration with other services as well. And I'll also mention this just in one moment. So integration with other Azure services. When I just started to work with Azure Cosmos DB, I had a use case when I needed to have a real-time data aggregation, real-time processing of the data that is incoming in my system. So the use case was for the logistics system, for e-commerce system, where we were distributing, delivering some beverages, some product goods to our customers. What we wanted to achieve with this kind of approach, with this use case, is to be able to give us suggestions to our customers. Like if you like a certain drink or you like a certain item, you also might like something else that are people in your region also liking. Or for example, that was also for us a case that we wanted to be able to calculate our stock information really fast. So how many items do we still have in the warehouse, or how many items are left in the shop? And for this, we were integrating with different Azure services. And as I already mentioned, we can use Azure functions. We can also use Event Hub that will be processing a lot of events in a really fast way. We can also have a stream processing. And as I mentioned before, we wanted to have a case of making a suggestions to our customers or calculating the stock information. So, well, in this case, the second icon, as you can see in the second section, is called Apache Spark. And Apache Spark can connect to the nodes of Azure Cosmos DB and in the background under the hood, and can do nearly real-time stream processing. So you can calculate your data, you can aggregate your data really fast. And you can also do similar things with Azure Cosmos DB, but when we are talking about really high amount of data, big volume of data, it will be just simply too expensive with Cosmos DB. instead if you would use just other Azure service. And as I mentioned before, you can also move your data from one place to another. You can connect to change feed and transfer all your data, basically having zero downtime and not shutting down your system for this. So your system can keep working while you're actually getting the data out and transferring it to another data store. It might be another Azure Cosmos DB. It might be blob storage or table storage. It's all up to you. So, as I said already about Materialized Views, Materialized Views is a very powerful approach, and with Cosmos DB, this is actually a really great way to go. And I want to say just a couple of words what it actually means, Materialized View, just a bit more details. So it's pre-computed data set derived from a certain query. So it's basically a query specification. When you have your logic, how you want to process your data, all this logic will be executed beforehand and stored for later use. So you will be able to really have a fast querying of your data, and it will be accessible anytime for you. Of course, that kind of approach will not just make things faster, that will optimize a lot of performance, that will create a single source of truth. So you will have already pre-calculated things, and your parts of the system will not need to recalculate every time the same thing. So you will have everything accessible, and all your parts of the system that require this set of the information will just read it without actually performing any action. And when materialized views can be useful. So it's, of course, sounds really great that you will receive a lot of benefits with the performance and faster queries, but there are certain recommendations, I would say, when it's actually make that much of a sense, or sometimes maybe you just have to go with those calculations. So first of all, when query result contain a small number of rows and or columns, and the second is query results contain results that require significant processing, including analysis of semi-structured data, aggregated that takes a long time to calculate. And as I already mentioned, for example, if you want to have a stock calculated beforehand, you would rather do this before. You would not want to calculate the stock for your whole warehouse where there's a thousand, maybe tens or hundreds of thousands of items. You would not be able to receive this information really fast. So in this case, Materialized View is really, really good. And every time when you make a change to your, when there is a change happening in your warehouse to your, for example, you sold an item or you received some goods, you would rather go with updating your Materialized View right away rather than trying to make the calculation or update of Materialized View on demand. So that kind of actions has to be done before the read operation will be needed. And the views base table does not change frequently. So this is just about Materialized Views. This is not specific just for Cosmos DB. This is actual general recommendation for any Materialized View approach you can have. But if you're talking about benefits of using Azure Cosmos DB for no-scale Materialized Views, for example, it's a reduction in cross-partition queries. If you remember, I already mentioned that cross-partition queries are leading to really high cost in Azure Cosmos DB. And what it actually means, I already explained that we are accessing few different machines, actual physical machines in data centers. And we don't want this because it takes much more effort and cost and resources to access data from one machine, then from another machine, then aggregate it and give us a result. Instead of this, we want to have all our data already pre-saved on one machine and be able to access it anytime from one machine, having really low latency and high availability. Reduction in RU charges for the existing queries. Again, as I mentioned, making our writes a bit more expensive, but our reads much cheaper will save us not only amount of request units for the read operations, but we will not have a need to do those cross-partition operations that will lead in much, much higher cost than actually writing more data beforehand. Improvement in query execution time. Well, you can imagine if you already have your query pre-saved, pre-executed, and available for you to read, you will have no need to actually execute anything, and you will have almost the instant read time, like a point read, and your operation, your query will be always the same. Your query result will be always the same for all the consumers. Zero coding efforts. I will show just in a moment how to actually create materialized view trigger in Azure Cosmos DB. So there are a couple of different approaches, as I already said, to interact with Azure Cosmos DB containers. But the new feature that was released in this year in May in build gives us opportunity to just execute a script to create some triggers or create a materialized view trigger on a container in Azure, and it will be managed by Azure. And also easy fine-tuning and monitoring of materialized view containers. So they also provide with this new feature, Azure provides monitoring of your state of materialized view. So as I already said, that I will just quickly show how does it look, how does script look actually to enabling materialized view feature. So this is the JSON file that will allow us to create a materialized view on a certain container. So if you guys are not familiar with actual like Cosmos DB and how to really work with this, how to work to do some automation, I assure you this is the very easy way. So you basically can just copy what you see on the screen, and there is a certain command to execute the script on your Cosmos DB, and this will work. So what is happening in this script, I will just explain from top to bottom. When you're creating your Cosmos DB, you have to provide a location where you're doing this. So basically, your region. And just in a few moments, we will go to portal and I will just walk you through the creation of a database. But you want to have your materialized view also in the same region, in the same location. So you're providing that you want to have, for example, in my case, it's West Europe. The tags and properties, the tags are not really important for us in this case, and they can be empty. It's not that I just remove them. They can stay empty. And the properties is actually what you want to do with your database. So the resource, the first thing you can see is the ID of my resource. So this is the ID of the container that I want to operate with. And the partition key, the path I'm providing by what partition key I want to aggregate my data. And when you normally creating a container in Azure Cosmos DB, this is the kind of automation this is the script you would use to just create a container. Without this bottom section materialized view definition, your script will look exactly the same for just creating a normal container. So executing the script normally on database, removing the second section will just lead to creation of MV users by name container with the partition key username. This second section, materialized view definition, is actual definition of what you want to store in your as your materialized view. So source collection ID is users. It means that it will try to look for the collection for the container in your database called users. And the definition is what kind of properties, and you will select from your container, and what properties will be pre-saved in your new container that you created just a few lines above. So as a result of executing this script, you will extract the fields as ID and username from the container called users, and you will store them in an MV users by name container. You will create this container first, and then you will store this information under the partition key username. So you will basically duplicate your data, but under the different partition key. And this will allow you just to much faster read the information like if you want to access my data knowing the ID of the file, that will be really fast. But if you want to access my data from the users container by my name, you will have to go through all the documents in there before you will actually find my document. So to avoid this, because this will lead to a higher cost, to avoid this, we will replicate our data in a separate container stored under the partition key called username. And then just having my name, you will be able access to basically having almost a point read operation. You will just access this document because you know the partition key. So as I already said, we will go to portal just in a second, and I will just walk you through a creation of Cosmos DB. I will start just from very scratch because I want to show all the steps, because I don't know who already worked with this or not. So as I already said, first of all, we are going to Azure Cosmos DB and we click the button create. And as you can see here, there's different APIs that you can use. As I mentioned already, there is a Cassandra, there is a table as well, there is a Gremlin, MongoDB, Postgres, or NoSQL. So I would just go with the default one, standard one, and I'll go with NoSQL. You have to provide the resource group, and if you don't have a resource group, that's fine. You can just create a new one. Let's click here and say test group, and I already have one test group, so I will call it just 2. Okay. Now I need to enter the account name. Let's call it Materialized Views Cosmos, just as an example. So usually if you would say something wrong, okay, like this, for example, it will tell you that you cannot have a name with uppercase, or you can only use numbers and so on. So then you're using a region. As I already said, that you will have your resources deployed in a certain region. So in my case, because I'm based in Germany, I'm in Berlin, I would just use West Europe or just Europe, which is the closest for me will be. And I will use serverless capacity mode. What it means, capacity mode, when you have provisioned throughput, it means that there will be by default certain amount of request unit provisioned for your account. So you can have, for example, 400 request unit provisioned. It means that you can do simultaneously 400 point read operations. Point read means that you spend only one request unit per operation. So with the provision throughput, you can also, of course, there's many different ways how to operate with this capacity mode. You can scale up, you can have auto scale, you can have a scale depends on the time of your day. Maybe you have a business that is more active during the day than in the evening, so you can do all those things. But I would choose to go with serverless because I know that I will want to pay only when I will be actually doing requests to my database, and I will not have any capacity, any request units provisioned upfront. But no matter how many requests I will be doing, I will be just paying for this. So, and then you can say review and create. And I'm not going to create a second one because I already have one pre-created just for this example. So working with Cosmos test, this is something I created just a few minutes before starting the session, just to have it ready because it takes a couple of minutes to deploy the resources. So what we can do, we can go to Data Explorer and we can just have a look what we have in Cosmos DB when it's very empty. So this is literally what is happening when you're just creating, you're receiving an introduction video from the Microsoft team about how to work with Cosmos DB. But you can also click to close this, and you can try to create something by yourself. So you can create new container. Of course, you don't really have yet databases in there. So when you're creating a new container, you will have to also specify a database ID. And this will be just pre-created for you. Let's say test database and container ID users and a partition key. As I already mentioned before, partition key, it's a property that is supposed to be in your document. So if I will be storing data that has no, for example, username, I should not provide the partition key as username, but I know that if I'm having users, I will definitely have a username in there. You can also have a hierarchical partition key. It's also a new feature that was released during the build in May, but we're not gonna go in there for now. So now we can click OK. And of course, it takes just a couple of moments to create the actual database and container. And while we're waiting for this, I will just jump back quickly to the okay, it's actually already created. Then I will just keep going here for now. So we have database and we have a container, and we can have items. As I mentioned before, this can be also triggers, functions, start procedures, and so on. But for us, now we're interested just to see what items we have, and it's of course empty. But as we can see here, there's ID and there is a username. So what it means that the ID of the document will be always unique and we have to specify it, but we can't duplicate it. And the username can be the same value for many documents. So let's just create a new item and just have a look how it looks when after creation, after the inserting this document in database. Let's say this is just 1, 2, 3, 4, 5, 6, 7, and username Okay. And there's a comma. So if we will now save it, as we can see, the item was created here. So we can see that there is a couple of properties were created automatically for us. So those things are not something we can or should delete or update or anything. This is what needed for a proper operation of database, a proper operation with those items. So this is a timestamp, basically the amount of ticks after the creation of our document, in the moment of creation of our document. This is the properties we specified. The rest is actually not something we should care about. And we can create more items like this. We can also, of course, do this programmatically through the code. We can have some more trigger storage procedures, and we can have many ways how to actually write data in here. And just saying a couple of more words about programmatical approach. So I will just give a short overview of how you can actually do the same thing that I did before, but using Azure functions. I know that might look a bit now overwhelming. I don't really know how many of you guys actually working with .NET or actually writing code, but I will just try to have a short overview of what is actually happening when you're working with Azure functions. So this is actual Azure function, and it's called create movements. This is an example from the times when I was working with the warehouse system, when I was creating the stock information for our business. So the create movements is actually just to store or react on the change in your warehouse. So every time you moved your item somewhere, I wanted to create a movement, to create a log of this information. And as I mentioned before, Azure functions can have different triggers and bindings. So in this case, I'm using HTTP trigger, which will simulate just a normal REST call. Like I will be able just to call this function, Azure function, from my mobile, from the web, doesn't really matter, from any client, I can call this function, knowing the URL where my Azure function is published and the actual route to this, to the function. And here is the interesting thing. This is the way how you operate with, how you work with Cosmos DB through the Azure function. So normally you would have to use SDK, as I was saying before, use for change feed processor. You will have to use an SDK, you will have to create a client, connect to Cosmos DB, maintain the connection, provide the container you're listening to. But in our case, we can use Cosmos DB trigger or binding. So that is just how it looks. This is an attribute, and we are specifying the database name and container name and the connection to our database. So afterwards, whatever is happening is just the processing of the data. And this is not really that interesting for us in this case. But this is just as simple as it is. If we want to get some information, I think this is already familiar. So this is the function name and the trigger. So how I'm going to actually call this function. And again, Cosmos DB trigger. So I'm just providing what database I'm going to be listening to and what container I want to access. And I'll just extract all the data on the moment when this function will be called and return it back. All these operations with Cosmos DB connecting to it, working with this, it's all done for me by those bindings, by those triggers. So we have the Microsoft Azure Web Jobs, like different libraries that are actually helping us to work with Azure Functions and Cosmos DB. So this is simplifying our life much more than we would work with change feed processor. And I will go back to the presentation because we already have our time almost done. So just a few more minutes. I want to say a couple of words about the limitations that we have for. If I will be able to switch the slide. Yeah. So what are the current limitations for the materialized views? As I already mentioned, this is a new feature and it was released in May. What I'm talking now about, what is the current limitations? They are related to actual feature of materialized view in Cosmos DB. So this script that I was showing before, if you would try to create materialized view using this script, so Azure will be actually responsible for maintaining, creating, and handling creation of materialized views for you. Those are limitations, and this is not a full list that you will meet. If you will decide to go on your own and you will use the Azure functions as I showed, or for example, change feed processor, you will not have those limitations. So you will have different limitations, of course, but you have much more flexibility when you are doing things on your own. So materialized view feature of Azure Cosmos DB is still very young, but very promising. So the few things I really want to mention, so this list is in front of your eyes and you can get back to it anytime. This is the same thing which is you can also find in documentation, of course. I didn't invent any of this, but I want to mention really a few things here. So first of all, where clause in materialized view definition is not supported. If you remember that I was showing a script and there was a definition of items, how I want to extract data from my container, there was select the property ID and user and name from the certain table or container. So you can say select all from or select certain properties from, but you cannot say any condition. So you cannot say where username equal this or this. This is not allowed yet. This is not a function that you can do with the built-in materialized view feature. In materialized view definition, aliases are not supported for properties or items. You cannot also rename your properties of items, so you cannot use aliases. And the last one, which is on this list before last one, role-based access control is currently not supported. This is the question I'm getting asked quite often. Can we do role-based access control? No, it's not yet supported for built-in feature. You can do a lot of things with Azure Cosmos DB, but not when you are using materialized view feature. And on this, I will stop. I will. I'm pretty sure that you can read the rest afterwards. And if you have any questions or you need to help to understand any of those limitations or recommendations that I was saying before, please feel free to write me even afterwards or now write in the question section. I will be happy to answer. But for now, I will wrap the session and I will say thanks a lot for the attention and thanks a lot for listening. So now I guess I will be waiting for any questions or wrapping up the session.
Brilliant. Thank you, Olena, for a great presentation. So we'll just get into the questions and answers part now. So like Olena said, if you have any questions, feel free to put them into the questions window now. So there's just a few questions in here, and the first one I see is someone wants to know, Does Azure Cosmos DB provide any built-in monitoring and analytics capabilities to track performance and gain insights from the data?
Absolutely, absolutely, yes. If I'm still sharing the screen, we can just go back here and I can quickly show here. So everything that you still can see my screen, right? Yes, you can.
Yeah.
So everything what you see here from this side is actual actual features that are like helping you to build your Cosmos DB better, to optimize your code, the cost to, and there is a whole section monitoring. So there is insights, alerts, metrics. You can set certain alerts. For example, if you are exiting a certain amount of request units per minute, per second, you can have your health state, you can have your certain metrics, so you can see the statistic, how it's happening, how is your like Cosmos DB working. There is some insights. So for example, if you deployed something and it failed or whatever, you will see here all the things, and you can like have much more. Like you can have a date restrictions, you can add some things, you can have the Azure advisor. So the Azure will actually give you some recommendation of what to do, how to do better if you're doing some obvious mistakes. So you can see there's a lot of things to work on with. You can have the diagnostics, actual like settings, and there is much more. So you can have also activity look, the overview of this. You can also have, if you're connecting, for example, Azure functions to your Cosmos DB, you can also have the healthy state of this integration as well. I hope this answers the question. So there's basically a lot of things, all those things that are related to Cosmos DB. So you can, for example, here you can also have like resource health state, and you can see if something happened with your Cosmos DB, it also will be visible here. There are some things that you have to enable additionally, but there's also default things that will be visible right away once you created a Cosmos DB.
Brilliant. Thanks a million, Olena, for answering that question. So there's just another question then here, and someone is asking, are there any security measures or best practices recommended for ensuring data protection in Azure Cosmos DB?
Absolutely. I mean, Azure Cosmos DB is like it's managed by Azure, so you can have as any Azure service, you can have the same more or less security level. The restrictions that I mentioned before about like role-based access, they are related only to this new materialized view feature. And if I will go back here, I can actually show here. So if you go here, feature, and you do this and you enable it, so in this case, you will receive the materialized view like separate tab, and in there you cannot do role-based access or whatever kind of advanced security. But the Cosmos DB itself, you can protect your data on many different levels. So you can do whatever security you're doing with other resources, with any other database in Azure, you basically can do the same with Cosmos. And there's like huge topics in discussion going on, like how to actually have a granularity of security of your data. You can do this on a container level, you can do this on database level. It is like there are a lot of things. So it's actually also here the separate tab for the access control and some privacy here as well.
Brilliant. Thanks a million, Olena. And then there's just one more question. So someone wants to know, are there any limitations or considerations to keep in mind when using Azure Cosmos for data processing and serving variable use cases?
Depends on the data processing. If I would need to process a really big amount of data, I would have a look in the integration with other services. As I already mentioned, there is Apache Spark, there's Hadoop you can use as well. I would like either Azure Synapse or some other services. If this is just like normal, like regular, let's say, if I can generalize like this, if this is just a regular amount of data as a normal system and there is no heavy calculations, you're not trying to make some, I don't know, aircraft calculations, for example, you can go with Cosmos DB. But what you have to watch out, there is two things. The first one is the hot partitions. So as I mentioned before, you will be storing your data in logical partitions, and they will be then afterwards stored in physical partitions. So if your data, if you use your partition key not properly, so you have to model your data in a certain way. So you have to evenly, when you choose the partition key, you have to be sure that your data will be evenly distributed between the logical partitions. If you don't do this, you will end up tackling the same logical partition, which will end up like calling the same physical partition under the hood much more than the others. So it means that you will do a lot of requests to one place but not to another, and it will scale up. Scaling up will lead to creating a hot partition. You will see this in like if you will create alerts, you will see this, but you will also see this just in normal logs that you have a hot partition. So one partition receiving much more requests than the other. This will increase your cost a lot because it will force the scale up. So what you have to be sure that you are evenly distributing your data across different partitions. And the second thing that I mentioned already is the cross-partition queries. So not just only you should not try tackling the same partition with many, like with lots of requests. You should try to avoid calling multiple partitions at the same time, because this will lead again to the low, like high cost and low latency, or high latency and low availability. So you'll try to access multiple machines and aggregate your data right away on the fly, which is not really a good thing. That's why Azure Cosmos DB, they saying, like the team of Azure Cosmos DB, they're saying replicate your data, duplicate your data. We provide you a storage cost, like it's really cheap. It's like 50 cents per gigabyte or something. So they're telling the recommendation, create as many duplications of your data as you want, as you need, but this will allow you to read much faster. If you will try to save the space but make real-time calculations, that will just lead in a really high cost. It will lead to the problems, and then there's a lot of complaints that Azure Cosmos DB is really expensive. It is expensive, but it's not that expensive if you know and you spend really time to understand how to process and how to model your data. That's all.
Brilliant. Thanks so much, Olena, for answering those questions. So that wraps up our questions and answers session. So just on behalf of the ESPC community, I want to extend a huge thank you to you again, Olena, for taking the time today to carry out this webinar. We really do appreciate it.
Thank you so much for having me. You know, like I'm speaking now, and I'm having in front of me like ESPC 22 small figure. I don't know if you can see it on the camera. So the last year I was speaking at the ESPC conference, and I'm looking forward to this year as well. So thanks a lot for having me. It's really my pleasure to share my knowledge with the community, and I hope that I will see some of you, or many of you, or all of you at the conference this year in Amsterdam.
Yes, absolutely. And we hope that we see everyone there as well. So that is the end of today's webinar. You can find this webinar and more at sharepointeurope.com/resource center. That is it for today, folks. Thanks again to everyone for joining us today. Take care, and that we hope that you'll join us again for more learning. Bye for now.
Thank you. Bye.